Hello, grade 9 students. Uh, this is version 4 of our lesson on variation. So the objectives: write an equation expressing direct variation, find the constant of variation and solve direct variation problems, solve inverse variation problems, solve joint variation problems, and solve combined variation problems. So in this lesson, we will learn how to solve word problems involving variations, involving the different types of variations. Write an equation expressing direct variation. If the value of one quantity depends on the value of another quantity, we can often describe that the relationship using variation. That is, in many applied situations, the ratio of one quantity to another quantity remains the same. So the formula to convert feet to inches is I equals 12F. That is, the number of inches is always a constant multiple of the number of feet. Okay, inches to feet yan. If we are traveling at speed of 55 miles per hour, the distance we travel in t hours given by d equals 55t. So distance is a constant multiple of time. In the first example, I equals 12f. As the number of feet increases, the number of inches also increases. Also, the number of feet decreases, the number of inches decreases. In the second example, d equals 55t. As the number of hours increases, the number of miles increases, and as the number of hours decreases, the number of miles decreases. So these are both examples of direct variation. As x increases, y also increases. As x decreases, y decreases. So the definition of direct variation: y varies directly as x if there exists some constant k such that y equals kx. If y varies directly as x, it is also correct to say that y is proportional to x. And in direct variation, for k is greater than 0, as the value of x increases, the value of y increases. Similarly, as the value of x decreases, the value of y decreases. And in any variation, there are at least two variables and a constant of variation. There are steps in solving a variation problem. Step 1, write the variation equation. Step 2, substitute the initial values and solve for k. Step 3, rewrite the variation equation with the value of k from step 2. In step 4, substitute the remaining values, solve for the unknown, and find the required answer. Start with y equals kx. Yes, this is actually the equation for direct variation. Y equals kx. Then after that, solve for k. Substitute known values, x equals 8 and y equals 24. So if x is 8, y equals 24, you can solve for the constant of variation k. You just divide y by 8. I mean y by x. You divide y by x, 24 divided by 8 is 3. 3 is the constant of variation. Yun, diba? Yun. 24 is divided by 8 is 3. K is 3, so that is the constant of variation. Now, given x or y, solve for the other variable. Let x equals 5, then y equals 3x. So from y equals kx, substitute k by 3. So this is now the equation of variation, y equals 3x. Now, if x is 5, what is y? Yun, substitute 3. Substitute x by 3 by 5. 3 times 5 is 15. Y equals 15. So that is how we solve direct variation problems. Okay, this is now a word problem that involves direct variation. The pressure exerted by a liquid at a given point varies directly as the depth of the point beneath the surface of the liquid. If a certain liquid exerts a pressure of 50 pounds per square foot at a depth of 10 feet, find the pressure at a depth of 40 feet. So it says here that the word here, directly. So this is a direct variation problem. So the pressure exerted by liquid, meaning P is equal to KD. P equals KD. That will be our equation. P equals KD because it says here that the pressures, the pressure exerted by a liquid varies directly as a depth of the point beneath the surface of the liquid. P equals KD. Now, next step is that we're going to solve for the value of K, the constant K, constant of variation, by substituting P by 50 pounds per square foot, D by 10 feet. So to solve for K, we just divide 50 by 10. So that's equivalent to 5. Right? Yun, 5. K is equal to 5. Divide. Divide P by D. That's a shortcut. P by D. Yun. So the variation equation is P equals KD. Substitute 50 equals K times 10. Divide both sides by 10. 50 over 10 is K. That's equivalent to 5. So the constant of variation is 5. So we will now substitute 5 here in the equation of the variation equation. So it will become P equals 5D. Yun. Now we have here the question. Find the pressure at a depth of 40 feet. Okay. Let us find P when D is 40. So 5 times 40 is 200. So this is now the answer. At a depth of 40 feet, the pressure will be 200 pounds per square foot. Yun. That's an example of a direct variation problem. Now we have here also direct variation as a power. One variable may be proportional to the power of another variable. So pwedeng y varies directly as x squared or x cubed. X to the fourth power. So y varies directly as the n power of x if there exists a real number k such that y equals kx raised to n. Examples of a direct variation as a power. Area of circle varies directly as the square of its radius. The distance an object falls varies directly as the square of the time it falls. Okay, let us try to solve a direct variation as a power problem. The kinetic energy of an object varies directly as the square of its velocity. If an object with velocity of 24 meters per second has a kinetic energy of 19,200 joules, what is the velocity of an object with a kinetic energy of 76,800 joules? So it says here the kinetic energy K varies directly. Okay, let us not use K because K is already the constant of variation, so we'll use E. E varies directly as the square of its velocity. So E is equal to kv squared will be our equation. Yun, di ba? E equals kv squared. Now let us solve for the constant. Substitute V by 24 meters per second, and then the kinetic energy of 19,200 joules. 19,000. Okay, ito na. E equals kb squared. From here, let us solve for k. Substitute E by 19,200, V by 24. Divide 19,200 by the square of 24, 576 is equivalent to 100 over 3. So 100 over 3 is our constant of variation. And we can now substitute this k here in the equation in the variation equation. Yun. E equals 100 thirds b squared. Right? Now, step 4. If the kinetic energy is 76,800 joules, find the velocity of the object. Yan, V. So what will we do here? Multiply 76,800 by 3 divided by 100. Or 3 over 100 times 76,800. Or pwede rin, yes, ganun. Cross multiply 76,800 times 3 divided by 100, which is equivalent to 2,304. But B is squared here. So B squared equals 2,304 by quadratic formula. Squared, get the square root of both sides. B equals 2,304, which is equivalent to 48. Alright, this is now the answer, 48. We only choose the positive velocity, okay? There's no negative velocity. So 48. Velocity is 48 meters per second. Yes, the velocity of the object is 48 meters per second. Okay. Now let's proceed to the next, inverse variation. Inverse variation, y varies inversely as x if there exists a real number k such that y equals k over x. So from this in an inverse variation equation, we can solve for k by multiplying y and x. Also, y varies inversely as the n power of x if there exists a real number k, such as y equals k over x raised to n. Example, for a fixed area, the length of a rectangle is inversely proportional to its width. Suppose that the time it takes to paint a house depends inversely on the number of members in the paint crew. As the number of painters increases, the time it takes to paint the house decreases. Yeah, so this is an example of inverse variation. Because if there are many members in the paint crew, then this will affect the time it takes to paint the house. So it will decrease. Kasi marami na silang nagpipaint, the time it takes to paint the house decreases. So as x increases, y decreases. So this is an inverse variation problem. Now, if it takes a crew of 4 painters 24 hours to paint a house, how long will it take to paint the same house if 6 painters work on the job? So this is an inverse variation problem. So what will be our equation here? Let n represent the number of painters and t the number of hours needed to paint the house. Since t varies inversely with n, we have t equals k over n. This will be our variation equation now for the given problem. K is the constant of variation, n is the number of painters, t yung time, or the number of hours needed to paint the house. T equals k over n. Now, to solve for k, let us substitute t by 24 and n by 4. And from here, we can multiply 24 by 4. That's equal to 96. That is now our constant of variation, k, 96. Then substitute 96 to the formula t equals k over n. So t equals 96 over n. This is now our formula, or the variation equation. And from this formula, we can now answer the question here. How long will it take to paint the same house if 6 painters work on the job? T equals 96 over n. So if 6 painters work on the job, it takes them 16 hours. So a crew of 6 painters will take 16 hours to paint the house. Yeah, that's an example of inverse variation problem. Notice that as the number of painters increased from 4 to 6, the time to paint the house decreased from 24 to 16 hours. Yes. Pag 4 lang sila, it takes them 24 hours, 1 day, to paint the house. Pero pag 6 sila, it will take them only 16 hours. So that's an example of inverse variation problem. Let's proceed to joint variation. It is possible for one variable to depend on several others. So for joint variation, y varies jointly as x and z. There exists a real number k such that y equals kxz. And so in inverse and direct, it only involves y and x variables. Pero sa joint, it involves sa joint parang direct variation, but it involves a third variable z. So quotient here. Yung end dito sa phrase na to, y varies jointly as x and z, it does not mean addition. Here it does not indicate addition, but product. Okay, x and z, so it means we will multiply x and z. So if we say y varies jointly as x and z, y equals k times the product of x and z. Ohm's law says that the current I in a wire varies directly as K. Ito naman, let us try to solve a combined variation problem kasi meron siyang direct and inverse. Kaya nag-combine yung direct variation and inverse variation. Ohm's law says the current I in a wire varies directly as the electromotive force E and inversely as the resistance R. If I is 11 amperes when E is 110 volts and R is 10 ohms, find I if E is 220 volts and R is 11 ohms. So pag I current in amperes, E represents electromotive force, In volts, R represent resistance in ohms. So since I varies directly as E, we have I equals KE. Inversely as R, so we have I equals KE over R is our equation, variation equation. Let us now solve for K by substituting I here with 11, E by 110, R by 10. Yan, 11 is equal to K times 110 over 10. We can cancel here. 110 divided by 10 is 11 divided by 11. So K equals 1. Diba? K is equal to 1. So this is our equation of variation. So substituting this in the variation equation, I equals KE over R. But since K equals 1, so I equals E over R na lang ang formula natin. Now let us answer here the question. Find I if E equals 220 volts and R is 11 ohms. So we'll just divide 220 by 11, which is 20 amperes. So the current is 20 amperes when the electromotive force is 220 volts and the resistance 11 ohms. So that ends our lesson on variation. This is version part 4. Okay, goodbye. I hope you learned something today. Have a nice day. Stay safe.